Next, we're going to be using multiple angle formulas to rewrite and evaluate trigonometric functions. Now on your sheet that I gave you, we have these different formulas all shown here that we're going to be looking at today. And the first one we're starting off with is our double angle formulas. And so we have our double angle for sine, cosine, and tangent. There's actually three different double angle formulas for cosine. And so for these problems, we're going to show how we will use those double angle formulas to solve. In this first example, we have cosine of our double angle plus cosine of angle x equals 0. Now, in solving these, we really want to try and get the same angle. So if we look at our double angle formulas for this double angle for cosine, here we have cosine squared minus sine squared. Here we would have 2 cosine squared minus 1. And here we have 1 minus 2 sine squared. So really, as far as best fit here, because of this cosine, I'm going to go ahead and substitute in here where we have just a cosine squared piece with it rather than bringing a sine squared into the problem. So I'm going to sub in 2 cosine squared minus 1 in for the double angle. So that piece is coming in, and I still have my cosine of the angle here. So now for me, I kind of think of this as a quadratic, right? If we have 2 cosine squared of x plus the cosine of x minus 1 equals 0. If I think of that as a quadratic, then I could solve that and factor it. So we have a 2 cosine and a cosine gives us our cosine squared here. And as far as factoring goes, let's see, that's a plus x minus 1 to get a negative 1 here. I'm going to have different signs to have this positive. I want to have my plus 1 away from that too. So I'm going to have a plus 1 and a minus 1 to give us our two different quantities. And now we can set each of those equal to 0. So we're saying that 2 times cosine of x minus 1 equals 0, and cosine of x plus 1 equals 0, and solve each of those. Here I would subtract the 1, so the cosine of x equals negative 1. What angle does cosine equal negative 1? And then here we are going to add the 1 and divide by 2, so the cosine of x is equal to 1/2. So now we're looking for what angle does cosine equal 1/2. Now, depending on the problem, if we're asked to give a general formula where we're talking about all possible solutions, here we know that we're going to have pi over 3 and 5 pi over 3 as our solutions within the interval of 0 to 2 pi, and here our value would be pi. If we're talking about all possible solutions, now we would take for each of those and say, well, my x is going to equal pi over 3 plus 2 times pi times n. X is going to be equal to pi plus 2 times pi times n, and x is going to be equal to 5 pi over 3 plus 2 times pi times n for our three solutions there. Next example, we're given that the sine of theta is equal to 3/5, and we're told that theta is in between 0 and pi. So first thing I want to do with that is I'm going to draw a triangle. We have our theta, given that sine is 3/5, and that's opposite over hypotenuse. We have 3 and a 5. We can use Pythagorean theorem to find the adjacent side is 4. So now we can use this triangle in solving this problem. The next thing we're asked to do is find our sine of 2 theta, cosine of 2 theta, and then the tangent of 2 theta. And so now this is again where we're going to go to our double angle formulas and plug in for cosine. You have options here. We can use any of those because we have our triangle to fill in those values and plug in to solve for each of these. So for example, for the sine, we have our formula 2 times sine of theta times cosine of theta. And so our sine value here is 3/5. Our cosine value with this triangle is 4/5. And we're taking 2 times that. So we're just multiplying our fractions here. So 3 times 4 is 12, and 5 times 5 is 25. We have 2 on the top there as well, so that ends up being 24 over 25, and that would be our value for sine. For the cosine, I'm going to use a different one than I did last time. Remember, we have 3 different formulas here. I'll use the cosine squared minus sine squared on this one. So we have cosine squared theta minus sine squared theta. We just said our cosine value is 4/5. So we're going to square that. And our sine value is 3/5. And we're going to square that. That ends up being 16/25 minus 9/25. When we subtract those, we get our answer of 7 over 25 for our cosine. And for our tangent, we have our formula 2 times the tangent of theta divided by 1 minus our tangent squared theta. So tangent, again back up here to the triangle, tangent's opposite over adjacent, so that's going to be 3/4. So we have 2 times 3/4 over 1 minus 3/4 squared. So I'm going to simplify top and bottom. I'm going to be multiplying here, 2 times 3. That gives me 6/4 on the top. And then when I square this, we have 1 minus 9/16. So to be able to subtract these fractions, we need a common denominator. So still thinking of my 6/4 on top. And now I would have a 16 over 16 minus 9/16. So that would be equal to 7/16. And dividing by a fraction is the same as multiplying by the reciprocal. So I'm going to take my numerator times that 7/16. And I'm going to flip that. So we have a 16 over 7. So now we're going to reduce the fractions. Multiply across. We have 6 times 4 is 24 over 7. And that would be my answer. Next we're looking at power reducing formulas. Our power reducing formulas on our sheet are here where we have sine squared, cosine squared, and tangent squared. And we are basically reducing these to having just a first power instead of having it squared. And so, for example, on this example, we're asked to rewrite sine to the 4th of x in terms of first powers of the cosines of multiple angles. So we want to get it down to where there's no powers on this. And so, first of all, sine is, as far as sine to the 4th, what we have here for a formula is sine squared. Well, I would know that this would be sine squared, and then we're squaring that. So if I think of my sine squared piece, that's where this comes from. We have 1 minus cosine. It's a double angle all over 2. So we have 1 minus our cosine 2x over 2, and we're squaring that. So now we have a double angle, all right, and we're still squaring this. We could think of this as our two quantities, 1 minus our cosine 2x over 2 times 1 minus cosine 2x over 2. And now we're going to multiply this. So I would think of that as 1/4 to get rid of the fraction piece. And now we're just going to FOIL the top. That would turn into 1 minus 2 cosine of 2x plus, then when we FOIL that piece, we get our cosine squared of 2x. So now still here, if we're going to have this written as first powers of our cosine, now we do have our cosine of multiple angles, we have that piece, but we still have our cosine squared. So back to our power reducing formulas, cosine squared, we could rewrite that as 1 plus our cosine. So still 1/4 of 1 minus 2 cosine of 2x plus, and now we're going to rewrite this of our cosine squared. Now notice this is just our u or x value, whereas here it's a double. All right, so that means that's going to be 2 times that to make it a 4. So it's going to be 1 plus cosine of 4x all over 2. Now at this point we've basically satisfied what we've asked here. We have it in first power. We have our multiple angles. We could simplify this a little bit more. All right, we could, for example, we could multiply our 1/4 across here. So we have 1/4 minus, let's see, 1/4 of that would make that a 1/2 cosine of 2x plus, that would change that to a 1 plus cosine of 4x all over the 4 times 2 makes that an 8. We could separate this fraction. So it would be a plus 1/8 for the first part, and then plus cosine of 4x over 8 for that second part. And then at this point we could factor out, we could get rid of the fraction and just have our cosines across here. As far as, let's see, it looks like the 1/8 would be our common fraction across there. That would make this first part, excuse me. So if we combine the 1/4 and the 1/8 here, that gives us 3/8. So when we factor out that 1/8, that would just give us a 3. And then we have the 1/2. So to make that equal, we'd have 4, because 1/8 times 4 gives us 1/2. And then our 1/8 times this just gives us our cosine of 4x. And that would be in simplest form. Next, we're going to be looking at our half angle formulas. And the half angle formulas are not on our sheet, so we will need to write those in on the back here. They are in the book, located on page 385. But what we have here is our half angle for sine, half angle for cosine, and half angle for tangent. Now for sine and cosine, we have a plus or minus. And to determine whether our value is actually positive or negative is dependent upon which quadrant that our half angle falls into. So first thing we need to do is determine the quadrant in which our half angle is, and then that's what's going to determine if we're talking about a positive or a negative value. So for this first example, let's say we're given the information that our sine of x is equal to 5/13 and that our angle x is in between pi over 2 and pi. So if we're drawing out our triangle, that puts us in quadrant 2. And so we have our 5/13 for our sine value over here. And so here's our angle x. And so 5/13 gives us our opposite and our hypotenuse. So then we can use Pythagorean theorem to find this adjacent side. And because we're in quadrant 2, that value is a negative 12. Now, as far as finding, for this one, we want to determine where the half angle would lie. So on this, we have our angle coming from here. Remember, we always start on this side and coming over to here. So there's our original angle. So a half angle would then be, well, let's cut this in half. Here we're in quadrant 2. So half of that is going to be coming around this somewhere, and it falls into quadrant 1. Now we know that sine, cosine, and tangent are all positive in quadrant 1. So our value, whether we're finding our sine, cosine, or tangent half angle, would be positive on this. Now for this one, we're going to find sine. So looking at my formula, we just determined that it's positive because we're falling into quadrant 1. So then our half angle, we're going to take the square root of 1 minus the cosine of the angle divided by 2. So looking at that, we have our half angle is going to be equal to, we said it's going to be positive, we're talking about the square root of 1 minus the cosine of the angle all over 2. Now using our triangle, we see that our cosine value is equal to negative 12/13. So what that means is that we're going to have the square root of 1 minus a negative 12/13 all over 2. 1 minus a negative 12/13. I'm going to think of this as a 13 over 13. So that goes to plus. That ends up being square root of. So we have 25 over 13, and that is all over 2. Dividing by a fraction is the same as multiplying by the reciprocal. So now we have square root of 25/13 times 1/2. So we'd be looking at the square root of 25 over 26. Now, as far as simplifying